All right, Science 10, Mr. Thompson here once again. Wow, we're having quite the day. If you look here, we're just finishing up section 1.3 on acceleration. And so we're looking at some graphical relationships here. So let's finish things off strong here. What we're doing is we're analyzing graphs with acceleration. So when there's an acceleration, the shape of a velocity time graph is going to be linear or a straight line. So you notice when it's a positive acceleration, then the line should slope upwards. Okay? Notice velocity is on the vertical axis, time on the horizontal. In the case of negative acceleration, the line will be still straight, it's still linear, but it tends down and to the right. Okay, so it slopes downwards. If you take a look at a displacement time graph or a distance time graph, either one, you're going to notice the following. Positive acceleration is kind of a curved line that goes upwards. Okay? Things are speeding up through time. And a negative acceleration is still a curved type graph. It's not straight, not a straight line, not linear. And so its slopes it goes downwards or curves downwards. I shouldn't say slopes. Its slope continually changes, but it does curve downwards. Okay, so try and recognize those types of graphs that show acceleration and what the direction of the acceleration is, whether it's positive or negative. This next one here, I wanted to show again, how you can analyze a graph. In this case, it's a velocity time graph. And so here is a set of data. I took the liberty right before setting this up that I would set up the graph already, get it ready for us. Okay, so I did kind of choose a scale and I put the graph on here, and I did notice three kind of regions here that we can analyze. One is, of course, the first time interval here, which is up to about, I believe, 7 seconds. And so 8 seconds truly. And then, of course, from 8 to 13 seconds, and then from 14 seconds to the end, okay, to 18. So describe the motion of the graph. So if we wanted to describe the motion, what would we really say here? Well, I believe in part, right? Part one in the graph, or the first part of it, the object is speeding up, positive acceleration, okay? So if I do the same thing I did before, which is to break it into these regions, call this region 1, call this region 2, okay? Call this region 3, and that's one way to go through it. Another way is to just get the time intervals and say from t, which is 0 seconds, to 8 seconds, it has a positive acceleration, okay? Speeding up. In the second interval, which would be time 8 seconds, until I believe it's, when does it start to change? 13 seconds. What we have here is we have 0 acceleration. It's staying a flat line here, so it's not changing its velocity, okay? And that last interval, which would be essentially 13 seconds until the end, okay? This is where you'd have a negative acceleration. Now to find the acceleration in these other parts, so here like 4 seconds and then 16 seconds, what you want to do is you want to look at, either the data and the graph does a good job because the line is perfectly straight along here, so the relationship is very much consistent. But what you're trying to do is you're trying to find the slope of the graph, okay? So in this case, I'm going to find the slope of section 1 here, the first one. And so in the case of that, I'm going to pick 2 points on it that I can use to analyze. I can look at 8 seconds, and then I can look at, the beginning interval, 0. And so the slope would be the rise over the run, which would be, what, 12.8, minus 0 all over the run, which would be 8 seconds. Now, if you put the units in here, you'll see that it's meters per second squared. So I'm going to try this on my calculator. You got 12.8. I'll subtract 0. It's not going to do anything. Divided by 8. I've got 1.6 meters per second squared. And that would really be consistent with the chart here. As you can see, it goes up by 1.6 meters per second with every second that goes by, all the way up till 8 seconds. What is happening from 8 to 13 seconds? I think we can see that the fact that there is no acceleration, and so maintaining a constant velocity. And then this last part, I just have a little bit more room here. So for part D, the acceleration at 16 seconds, what you'll do is you'll find the same idea, right, applied, which we did in part B. So we'll find the slope of section 3. Okay, so in the case of finding the slope, what do we do? Well, same idea, rise over run. And here what I'll do is I'll take the last point, which is 0.8, subtract away the point back here, which would be at 13 seconds, 12.8. And then I'll divide that by the run here, which would be 18 seconds. Subtract away at 13, and we're ready. Okay? So this will be in seconds. This is in meters per second. And the calculation gives me this. So 0.8, subtract away 12.8, and I want to divide that by 5. Negative 2.4. Okay, thank you very much for joining me on that. Next day, what we're going to do is we're going to look at acceleration due to gravity. Have a good day.